Now, DC voltage, the title of our chapter. DC stands for direct current. Direct current voltage. DC voltage means direct current voltage, which means that the current flows in one direction only, which is from the positive pole of the dry cell to the negative pole. The electric current, the electricity always moves from the positive pole to the negative pole. From the positive pole to the negative pole in one direction. So it means that the voltage remains constant with time. It doesn't change with time. The voltage is not variable. It's always constant with time. Just like the electricity given by the dry cell. They give us a DC voltage, which is a constant voltage, not variable. And this is the symbol of DC voltage. It's like this. So when you see this symbol, it means DC voltage, like the electricity given by a dry cell. So two terms are mentioned here, current and voltage. These two terms are extremely important in electricity. They are related to each other, but they do not carry the same meaning. I'll give you an example in order to know the meaning of current and voltage because they are important to know. Let's assume we have a football player. We'll assume that his energy is the voltage and his movement, his motion is the current. So if this player is healthy, he's eating well, everything is okay with him, he's sleeping enough, then he has enough energy. So his motion, his current will be also normal. If this player is sick, he's not eating well, he's not sleeping well, no enough energy, no enough voltage, then his motion, his current will be too weak. If this player is healthy and everything is okay with him, and in addition to this, he's taking activators, some pills to activate him more. So he will feel that he's not tired, he has too much energy, too much voltage, then his current, his movement will be too quick. But in case of overdose of these pills, he might die. The same as for the lamps. The lamp needs energy, needs voltage, electricity to make it glow. The dry cell can give the lamp this electricity. So electricity is given by the dry cell as a DC source. So if the dry cell gives the lamp electricity voltage, then electric current, electricity will move in the circuit, in the lamp to make it glow. For example, if the lamp needs 6 volt in order to glow normally, if we give it 6 volt, if it's connected to a dry cell of 6 volt, then electric current will move in the lamp normally and the lamp will glow normally. If the lamp needs 6 volt as an energy and we gave it, for example, 3 volt only, not enough voltage, not enough energy, then electric current will move slowly in the circuit and the lamp will glow dimly or weakly. If the lamp needs 6 and we gave it too much voltage, too much energy, for example 9 volt or 12 volt, more than 6, then electric current will move quickly and the lamp will glow brightly, very strong, but it may burn out. The same as for the player. Look at the comparison. So voltage is the energy in order to push the electron and to make electric current to move. Electric current is the quantity of electricity that is moving in the circuit. So in order to measure the current and the voltage, we need a device to measure them, and it's called the multimeter. This is a multimeter. The multimeter is a device used for measurement to measure the voltage and the current. So we can use it in order to measure the voltage and the current. So the multimeter is a device that can be used as a voltmeter to measure the voltage or an ammeter to measure the current. So it's called multimeter because it has many functions, and meter, it ends with meter because it's a device for measurement. As you can see that the multimeter has three openings here. One opening is A, the second V, the third COM. So when we wanted to measure the voltage, then we must use it as a voltmeter. We connect it from the V and the COM. If we want to make it as an ammeter to measure the current, then we connect it from the A and the COM.